Okay, today we are going to demonstrate DHIS2 install in a distributed setup. My environment is a Proxmox infrastructure. I have node 0, node 1, and node 2. Within these nodes, we have virtual machines. In node 0, I have proxy and a deployment server. And in node 1, I have PostgreSQL database. And in node 2, I have DHIS2, Tomcat server, and monitoring server. The Proxmox infrastructure setup is going to be like a separate call on its own, just explaining how it is set up, the Ceph distributed storage and so forth. Right now, I'm going to just mention that I have two networks. One is the virtual machine networks, local area network, and another storage area network that Ceph is using underneath. So the deployment server really needs to have SSH connection to the proxy, Postgres, and DHIS2 server and the monitor just to run the deployment. Distributed installed is using SSH as a transport protocol, the connection protocol. And it needs to be working. Yeah, you need to just ensure that you have that connectivity and that the SSH connectivity works to the old host. You can go ahead and I have like pre-deployed and provision all these servers and they are ready for the deployment right now. Going back to the terminal, I can log into the deployment server. It is in it's running in .40 and I've got permission denied public key. Okay, I'm gonna just get my deployment key. It's usually in KeePass. Yeah. So right now, I should be able to, yeah, it's loading from the KeePass. And right now I should be able to connect. And from within this deployment server, I can test connections by just pinging the backends. Ping 172.21.0.19 is the proxy, and then .20 is the PostgreSQL, .21 is DHIS2 instance, and .22 is the monitoring server as explained here in this diagram. So we know that the connectivity works. So step number 2 is to ensure that SSH works. Let's try SSHing to 172.21.0.19. Okay. And indeed, yeah, the port is open. That is why we're getting this to this step. So that means port 22 is open and it's listening, but I'm denied public key. The same goes for 20. Yeah, I'm denied public key. 21, denied public key. 22, the same goes. Yeah, yes. Because all these servers have been configured in a way that they do allow connection only with authorized keys, SSH keys. Password authentication is disabled. Okay, so I'm going to log in from my machine here, and we're going to see, maybe see what we have right now. Let's start with the proxy.19, and I'm logged in, fim.ssh authorized keys, and as you can see, it has the my SSH key downloaded from the launchpad. Another one is coming from GitHub. I have two keys from GitHub. So all of them are like loaded here right now. So that means we don't have any key from the deployment server. And ls minus nothing is inside .ssh right now. There's no key. So we need to generate SSH key pair with SSH key gen. With the defaults, we're now gonna have two keys. We have a key pair of ID ED 25519. So the one that we need is the pub key to upload to all these backends. Cut that one. This is the key that we can upload to all these server backends, starting with the proxy, going to the next, which is PostgreSQL.20. And here we can just again append the same file, vim.ssh authorized keys. At the very end, append the key for the deployment server, and .21 vim.ssh authorized keys. I can again append the key for the deployment server. The user that I'm logging in is the default user, which is KT. So even the deployment server is going to be logging in and running deployments with this same user. The last but not least is 22 monitoring server .ssh authorized keys, append its key. Okay, and then we can test connection now from the deployment server. And I'm going to use Tmax cd SSH 172.21.0.19. This is the proxy. SSH 172.21.0.20. This is the database. And SSH 172.21.22. SSH 172.21.0.21 is the one that we need to test now, connectivity. And as you can see, we can log into the proxy, Postgres, DHIS, and monitor. So we can run our deployment now. The underlying transport that Ansible needs is working at this very moment. Let me exit from all this, back to the deployment server. Okay. Now, we have proxy VM here, it's on .19. We have PostgreSQL, it's on, deployment server on .40. And then we have PostgreSQL in a separate physical server node 1. It has .20 as its IP address, and DHIS instance, a separate server has .21. So they are actually running from different physical servers. But Proxmox is a cluster. It's like they operate as if they just, everything out from within the same server, and the interconnectivity and so forth. You can even log into the console and whatnot. But Proxmox and taking you through all this is a separate call on its own. So I wanted to just show you the distributed install steps here. DHIS2 server tools, there's this section installed on a physical virtual servers. Typical cluster is Proxmox. You can use VMware cluster if you want, KVM, Zen, or whatever. But the underlying transport connectivity for the controller and the backend managed instances is usually SSH. Okay, yeah, as shown in this diagram here. So yeah, so we've tested that we have connectivity with ping. We've also ensured that we have working SSH connection from the deployment server to the backend managed hosts. Step number 2 is now from within the deployment server, you need to have at least host-based firewall UFW enabled just to secure that server here. Sudo UFW limit 22 TCP. Okay, and then sudo UFW enable just to enable the firewall. And after that, we are good. Sudo UFW status. Yeah, we have the firewall enabled, and we can go ahead with the next step. Step number 3 is basically installing Ansible controller. You could do that, but we are skipping that today. We're going to just grab the deployment tools from GitHub, git clone, or just paste that. So it's going to download deployment tools. And after that, we need to create an inventory host file from the template. So let's go to the directory cd server tools deploy and copy inventory hosts template to inventory hosts. Okay, and then we edit inventory hosts. So there are 4 important variables: FQDN, fully qualified domain name. If your proxy is sitting somewhere in the internet with reachable public IP address, then you can use fully qualified domain name. You have the domain mapped to that real public IP address, and with Let's Encrypt, you can get certificate assigned. Even the tools support generating Let's Encrypt certificate. And also the email, by default, it's gonna generate admin email from your domain. Yeah, it's like concatenating admin at your domain, but you can put a separate email, real email, that you can use rather get updates when your certificate is expiring or about to expire, so that you can be able to take action before it expires. Time zone, this is the time zone that your server is going to be running. Importantly also is the connection that you're going to be using. If you check the inventory host file, Ansible connection, it is by default LXD, but you need to change this to SSH. Variables that apply to all hosts within this inventory host file. Okay, if you set it here, it's going to apply to all the hosts that are defined in this inventory host. Next is the IP addressing for my servers. The proxy is having .19, so I'm going to change my inventory host file so that it reflects that inventory host and change this. Okay, and put the real server IP address for my proxy. Number two is Postgres. Okay, Postgres is running on .20. Okay, so I need to copy that and again go back to the terminal, go to the line where you have Postgres. Okay, and okay, I'm gonna put equal sign and paste .20. Okay, so we have .20 right now for Postgres. Go back again to the diagram. DHIS is having a separate 21 and monitor.22. So go back to the terminal and you edit the IP address for the terminal for the DHIS. Put .21. The same goes for monitor. This is .22. Yeah. So we have IP addressing scheme reflecting what we have in our diagram here. So an SSH, we've tested, it's working. We can leave other defaults like proxy to be Nginx, time zone to be Africa Nairobi. The version of DHIS2 that is going to be installed is going to be 242, the one that is defined per the instance line is going to take precedence. Okay, right and quit. So we are done with all the up to the step number 6. At least we have the important variables like Ansible connection and time zone, and we've set IP addresses for all the instances. Here it was using Ansible to ping, but we don't need that because we skipped step number 3. So that means we don't have Ansible right now, and we cannot like use this to ping. We just pinged it manually in our case. I want to explain also these few connection parameter like Ansible playbook parameters. Like if you run Ansible playbook, you use -u username. If you have your backend servers using different name, then you can say Ansible user for proxy, for example, is maybe Ktito or any other different user. Then Ansible is going to use that to connect. Same goes for Postgres. But for me, the default user, I don't need to add anything else. Who am I? See, we have the default login user is Ktito. So you can come here and put to be the user that you have specifically for yeah. But connection is not enough. You're gonna need a way of your Ansible controller connecting to the backend, and perhaps your SSH is using password. Mine is not, but if it was using, it's gonna be asking you for the SSH password, defaulting to the SSH user that you have logged in with. You are logged in with. And number 2 is gonna ask you for the become password. Why? Because for it to be able to install Postgres, for example, or proxy Nginx or Tomcat 10, it needs sudo. So Ansible needs to have a way of, asking you for the sudo password for that to be used for the installation of stuff in the managed host. Another way that you can mitigate that is using sudo pass connection, variable. You can come here and say sudo pass for the proxy server is not, it's different. Maybe it is Nairobi. Okay. And of course, that is actually the password I'm using right now. Could be something else. Okay. Could be, yeah. Um, yeah, and even that for PostgreSQL could be something else. But this is how you define it, and this is going to take precedence really, so that even if you're prompted for the pseudo password and whatnot, um, whatever that you have defined here is going to take precedence. This is not good practice because it's storing your pseudo passwords in plain text. Good practice really is to, if you're going to be having all this in your inventory host file, then you need to encrypt your inventory host with Ansible Vault, yeah, which is also beyond the scope of this code. But yeah, that I was just trying to explain a situation where you could be having different pseudo passwords for different servers. So then you need to at least be using this variable. Perhaps PostgreSQL is Nairobi, and so forth. Yeah, yeah. But we are using Nairobi for just for demonstration purposes. Next is and of course the script is going to prompt for the sudo, so that even for the hosts that do not have sudo Ansible sudo pass defined, the script is going to prompt for the default sudo pass that is going to apply for all the others that do not have sudo password defined. Okay, now I think the next step is just to run deploy.sh sudo deploy.sh. So what is happening here right now is that Ansible, it's a chicken egg situation, right? You need Ansible uh, orchestrator before you run the playbook and automate deploying things on the backend server. So that is why even in the documentation here, the very first step was to install Ansible before you even clone the tools. But I skipped all this because deploy.sh script is installing Ansible. It has that part. If you go back to the deploy, you go into the deploy and you go to the install.sh install.sh script or deploy.sh script, you'll see that it has paths where it is installing Ansible, like this one, all this. So that is already captured in that section. Okay. So from within the script, it is installing Ansible before it tries doing things in the monitored hosts. Okay, going back to the terminal, you'll see that that is the first step that is happening. It is automated from within the script, and then after that, it's going to ask for the connection parameters. It's not basically asking for the username. For the username, you need to at least have them in your inventory. Okay, like this cd.vim cd dhis2 server tools deploy vim inventory host. For the usernames, you need to have them defined, like either Ansible GG, Ansible user. You need to have them defined like that if you're using different usernames. But for me, I'm using the same user, KTito, everywhere. So I don't, it's going to ask just for the SSH password. It's going to ask for the SSH password. And after that, again, sudo password. Okay, let's wait and see what happens. I'm going to mention that I am running all this from my home infrastructure, and my home infrastructure is with the internet is not good. I can demonstrate that quickly with speed test. Okay, maybe Tmax. I had another Tmax session here. You see, the Linode gives you up to 1.6 gigabits per second, but my home network is giving me, around 18 and 2.75 megabits per second upload. So fairly, you know, it gets the work done, but it's very, very slow. That's why it's taking even long to just install Ansible here. But once that is done, then it proceeds with the first task in the playbook, which is just installing PostgreSQL database within PostgreSQL Server. If you log into PostgreSQL Server right now, okay, let me just exit here. Okay, clear SSH 172.21.0.2020. You see that there's nothing. There's going to be nothing. SS minus -p, nothing is installed. It's just SSH listening on port 22. But after a while, you'll see things start appearing. things will start appearing. Yeah, let's wait and see. 1 second. It's gonna prompt for my SSH password, which in our case we don't have it. Well, we have it, but our servers are not allowing SSH connection. So we have set up key-based authentication. So we just hit enter. Become password is important because we haven't defined Ansible pseudo password for all the hosts. So we're gonna need the default. Okay, we're gonna need the default, which is I've just applied the default password. Sorry for the interruption. And it's going to proceed now with the installation of stuff. Yeah, it's going to proceed with the installation of stuff right now. On the first of all from within the host here, and then it's going to do that also on the backend monitored hosts. Okay, let's wait and see. Yeah, now it's doing things on PostgreSQL database. Okay, with the supplied pseudo password here, it's going to do things on PostgreSQL. But for PostgreSQL, if it's even using Ansible, we had to put password to be Nairobi. That is what is actually being used behind the scenes. Okay, so it's installed everything right now, like access control list, ACL package. It's setting the time zone to Africa Nairobi, the same that we set in the inventory file. It's allowing port 22 for SSH because you need that. And then it's going to install PostgreSQL 16 because even if you go to the inventory host file within the deployment server, you'll see that the PostgreSQL version, you'll see 16 somewhere. See, PostgreSQL version was 16, so that is what it's being actually installed right now. Yeah. Yep. So that is going to take a while because internet is not that fast for it to be able to do that quickly. So it's installing PostgreSQL 16. Yeah. So the PostgreSQL right now, you see, it has nothing. Okay, it doesn't have anything right now. But the install is going on right now, and after a few seconds, you'll start seeing something listening on port 5432. I'm just gonna monitor that live as the install is going. It's happening from the other window, from this window. I'm monitoring here. Nothing, because the install is continuing. Okay, maybe we can go back to the Proxmox environment. Yeah, I showed you. We have this node 1. It has proxy. On .19, on .20 we have on .40 we have deployment server. On .202 we have node 1, which is our second node. We have PostgreSQL listening on .20. Things are happening here right now. And on the last node we have DHIS, and we have also monitoring server. All these are running across 3 nodes. There is heavy networking is happening between all 3 nodes here. Ceph, you see there's a Ceph storage on node 1, there's local storage, there's Ceph storage also on node 0, there is Ceph storage on node 2. You can check the replication for the Ceph if you want. Infrastructure, okay, data center, Ceph. You see, we have 3 nodes. It's healthy. All the nodes, are up and are healthy. Participating well in a cluster distributed storage for the Ceph. So what happens is that if in any case my node, one of my node goes down, say due to power outage or other reasons, then everything that was running on that node are going to be migrated, because the Ceph is the underlying distributed storage that is configured for node all node 0, node 1, and node 2, for high availability, for moving VMs. When you move a VM, for example, from say node 2 to node 1, you're not actually moving storage across. You're actually moving the config, the CPU, the RAM settings, but the storage is all the time replicated. Ceph, that is what Ceph is doing. But it comes with the downside. The downside is that it's heavy on the networking, right? Because remember that if you're running SSDs, or if you're running SATA SSDs or M.2 SSDs, you can achieve on average, I think, 6 megabits per second read and write bandwidth, overall bandwidth. But your storage, sorry, your networking, yeah, unless you're using fiber channel, or you're using fiber links, but if you're using Ethernet, right now I'm using 2.5 gig Ethernet. It means that my bottleneck reading and writing to this Ceph is basically the networking, yeah, the storage backend networking, and not necessarily the speeds that you can read and write from this disk, because they are SSDs essentially, M.2 disk, and another one is other two are SATA SSDs. So yeah, and this is basically a typical data center in most of the on-premise environments. They're running Proxmox or they're running VMware, and yeah. So if you want really to have that disk perform, read and write perform nearly to the bare metal, then maybe you can run even your PostgreSQL from a directly attached storage. Then you're able to maximize on the capacity that your M.2 SSD is giving you. If it's giving you, say, 20,000 megabits per second read and write bandwidth, and of course it's very low latency, because the communication between the server, the VM, and the backend is just wire speed, right? And the latency is very slow, very small, and for that reason, you're gonna have high bandwidth, low latency communication between your server and the storage backend, and that is good for PostgreSQL. Yeah, let's check what's going on now. Going back to the terminal, yeah, right now we've completed task related to setting up PostgreSQL. If you go to this screen now and run ss-10lp, you'll see that we have indeed PostgreSQL listening on port 5432 on both IP version 6 and IP version 4. Yeah, then you're going to ask yourself, is this good for security? Yes or no? No, because PostgreSQL right now is listening on all the ports. I can create another window here and telnet .20, and you see I'm connected. It means whoever is sitting in your local area network can connect to your PostgreSQL. And why is this? It's because that section where that firewall configuration for my PostgreSQL, that task, Ansible task, is not yet run or played, and that is why you see your PostgreSQL is still like listening everywhere. But the other thing about PostgreSQL is that it has different layers of security. It has pghpa.conf, it has host firewall. You could even have perimeter firewall restricting access to the PostgreSQL database, so that it allows access from the host that you want accessing PostgreSQL. You can use different file. Yeah, I've tested pfSense. You can have that even restricted on your router and so forth. And you can even have like, data center firewall doing that for you. That is first layer of defense. Then you have host-based firewall, UFW, second layer of defense. pghpa.conf is access control list on PostgreSQL server itself, that layer of defense. use very strong password for your PostgreSQL user. That is the fourth layer of defense. You can even configure pghpa.conf so that it's not accepting an encrypted traffic. Host SSL, fifth layer of defense. So this is what we call defense in depth. Like you don't, if one thing is compromised, if your firewall is compromised, then you still have host level firewall. If your host level is compromised, then you still have PGHPA restricting access from whom, from only say DHIS2 instance only. If that is also compromised, then you still have your PostgreSQL user and password using strong password, and that is what is happening. And at the end of it all, we can verify that that is what all this Ansible script is doing. So right now it's in the step setting up the proxy. Yeah, still PostgreSQL right now, sudo fw status, still yeah, it is not activated, it's not enabled. Yeah, so I can still connect from here, but after a while it's going to be restricted, and only DHIS user here is going to allow access only from the DHIS user. Okay, it's going to only allow access from here from the DHIS user to the PostgreSQL database. I'm gonna check that. We're gonna verify that once the install is completed. So the only reason why this is taking a while right now is because I have my internet connectivity is not that good. Yeah, yes. But meanwhile, I can talk about other things. Let's just go to the inventory host now. Other things that at the end of this, you're going to have server monitoring enabled. And the server monitoring, let's check, what is it monitoring? Yeah, we have server monitoring set to monitor, that's the default. But you can also set this to Prometheus, Grafana. And your server monitoring that you're going to get in your stack is Prometheus. The proxy that is gonna be installed by default is Nginx. Yeah, but you can also enable supporting Apache 2 or OpenResty. These two proxy software, OpenResty, for example, is an open, it's like an Nginx with Lua support, so that you can do even scripting on top of just basic Nginx binaries, so that you can maybe manipulate how you want your traffic to be modified, and before it's passed to the backend. Yeah, so right now the script, let's check the script. How far is it now? Yeah, so it's still generating. This is usually a CPU intensive process where, like, it's any cryptography here, generating the generating the Diffie-Hellman key parameters, key exchange parameters. It's gonna take a while. It's gonna pass this step and proceed with the install. Yeah. Still, PostgreSQL is open to the world, but after the install is completed, you're gonna have everything restricted. Yeah, I'm gonna talk about using custom TLS certificate. For us here, we are using self-signed TLS certificate. Why? Because we don't have fully qualified domain name. If we had fully qualified domain name, then you could potentially have your own SSL. Maybe you purchased it somewhere else for your domain, and then you just use that. Usually 1 year certificate, SSL certificate, and then you just use that. Or you could use Let's Encrypt. What happens is that you just automate the whole process of requesting certificate with Subbot, for example, from Let's Encrypt, and that is going to enable you to run fully trusted site with Let's Encrypt certificate. The reason why we're not doing that, as I mentioned, I don't know if I've mentioned that, but it's because our environment is local. Like, this is not a public IP, it's just a private IP address, right? And the only way that we can be able to access this instance is just putting the IP address. But I'm going to demonstrate in another call how I can expose this to the outside world, either using VPN like Tailscale or Headscale or WireGuard, and or use Cloudflare tunnels for that matter. You can use Cloudflare tunnel where you have Cloudflare sitting in front, all the traffic is hitting Cloudflare, and Cloudflare is going to route all your traffic back to the infrastructure here. Right now, we're just going to demonstrate installing DHIS2 from a distributed, from a central point, where in this diagram is the deployment hub. I have Ansible installed here, even locally in my MacBook here. Ansible, see, I could have run the deployment here, and you notice that I'm able to access all these backends from here. Yeah, I could have run my deployment from here, but it's not usually a good practice because you want to detach. You want to detach, the deployment server from the personal computer, so that anybody else tomorrow can just go into the deployment server, be able to run the deployment from there, or learn how the setup was set up from there. Because if I do set up this environment from my computer and tomorrow I'm not, maybe, it's my personal computer, it means maybe somebody else from the organization is not able to access my, it's not even able to understand what was happening in the beginning with regard to deployment. So you need to have another separate standalone server sitting actually from within the data center, and connecting to the backends in a trusted, um, within the trusted network, which is the case here. And yeah, so yeah, I could have done that, but yeah, this is the best practice. You need to have the deployment server, actually real genuine server from within the data center itself. Okay, let's see what is happening right now. Okay, going back to the terminal, Control B. It's here. So we are past the step of setting up Nginx proxy, and if you log in to that server right now, SSH 172.21.0.19. This is the proxy. You'll notice you're gonna have port 80 listening SS minus standard P. You see, we have port 80 listening, and I can check also the firewall status, sudo efw status. The firewall status is that it has only port 80, 443, and 22 allowed on the firewall. Why port 80 is because you want so that when you access the site, say this site, from your browser, you don't need to specify HTTPS all the time. You can just say 172.21.20.0.service.19, and it accepts that, because by default, when you type the IP address like this, it is usually HTTP in the, it's not HTTPS. Even the domain, if you type the domain, say dhis2.org, docs.dhis2.org, if you don't specify HTTPS, the protocol that you're using here, it assumes it's HTTP first, and then it's going to upgrade. Okay, the server itself is going to upgrade HTTP connection to HTTPS, but you're not locking people out, those who do not specify that they want to go to the HTTPS endpoint. Okay, so that is why we have that port, but within the Nginx configuration, we are redirecting permanent rewrite of all the HTTP ports to HTTPS port, secure port. Number two is that if we had fully qualified domain name and this server is sitting in the public, okay, then you're going to be requesting your server, if you're using Let's Encrypt, your server is going to be requesting certificate from Let's Encrypt. And Let's Encrypt is going to be using port 80. It's expecting your server to be listening on port 80 for it to be able to authenticate that you are the real owner of that server and issue certificate for you. Why? Because you cannot use port 443, secure port 443, and yet you've not even gotten certificate. It's a chicken egg situation here that you need first an encrypted verification, authentication happening before even you issued certificate, and then now you can, upgrade all the traffic going forward, so that it goes to that secure port 443. So you're requesting certificate before you get certificate. So you cannot use for port 443 before you even got the certificate. Okay. So that is why Let's Encrypt is using port 80 first to get certificate. But if you keen and check how Nginx is configured, you'll notice that Nginx is accepting all the requests on port 80, and then it's redirecting everything that comes to port 80 to port 443. Our third bot is usually using this is a standalone. What is that? Standalone is that when you try to request the certificate, it is going to stop all the server that is running. If it was Nginx, it's going to stop Nginx first and then request certificate listening. It's like a standalone server that is going to be listening on port 80, request certificate, write the certificate, get the certificate and put it in a disk, and then it's going to start Nginx after it has like sort of got the certificate. It's a standalone. You don't need Nginx or Apache or OpenRestit for you to be able to get the certificate from Let's Encrypt. It's gonna run its own standalone server. It's what it's another way that you can use Sandbox to get certificate and Let's Encrypt certificate without necessarily having a server running locally. Yeah, if you want to have a server running locally, then you can use the path Acme, well-known Acme, path for the verification methods. Okay, let's go back to the install. Right now, it is in the create instance step, right? And you see it's created. It's now creating instance like installing Tomcat and so forth. But if you go to the PostgreSQL now, you'll notice that the firewall is enabled and it's allowing connection from three, it's opening three ports. One is 22 because it's a standalone server and it needs, this is how the administrator is going to be connecting to this server to do things, to do backups, whatever. And number two, port 4949 is the Munin server. Okay. The agent is listening here on port 4949, and the Munin server is connecting to the agent and it's polling PostgreSQL status, polling and monitoring PostgreSQL, and even the host itself as a server. There's also port 5432, but notice that port 5432 is listening only on 172.21.0.21, which is our DHIS2 instance. Okay, it is not allowing, even right now, if I go back to this other window and try telnetting, I tried before and I was able to connect. Right now, nothing is happening. I'm no longer able because it's got to that step where the task is run and the task is restricting access to the PostgreSQL only from specific IP address. I can try and edit it, see PostgreSQL 16.PDHPA.conf sudo. You'll see that at the very end, we have, again, another access rule that allows access from .21 again, and with a specific username and specific to specific database. Okay. Yeah, this is what we call defense in depth, and it's only allowing SSL encrypted connection from that server. In essence, any communication between the DHIS2 instance and the backend PostgreSQL, even though this is within the private network, it is still encrypted. So you don't even need to have complicated issues and have, say, VPN between the PostgreSQL backend and the DHIS2. That still is encrypted. And anybody else trying to connect to the PostgreSQL server is going to be thrown out because there is no line allowing access from even the LAN. If you wanted to access, to allow access from all the servers in this network, you could say 0/0 and then /24 wildcard mask, allowing access to the whole subnet. But that is not the case here. It's allowing access from specific. See, the wildcard is /32 from specific IP address. Okay, I'm gonna just exit without writing anything. Yeah, you've seen that. That is what I was explaining before. That after some time, that is gonna be hardened, like the PostgreSQL from the network level, from within the server level is gonna be hardened, and we've actually verified that. So right now it's basically doing Nginx configuration. It is using self-signed certificate now for the Nginx, generating private key and public key, self-signed certificate, so to speak. Yeah, so those are the steps. And after a while, we're gonna have our data to accessible on plain IP address. Okay, let's go back to this window. Okay, go back to the proxy, exit first. Okay, this is the proxy, cd/etc nginx conf d. This is where the Ansible puts the configuration. Do we have any configuration now? Yeah, we have default, theme default. Default is having nothing. Oh, permission denied. I need to exit and use sudo. You see that it has the upstream configuration. That is, it keeps, we are using upstream configuration for the Nginx proxy to keep connection to the backend, and you can configure keep alive, request, how many requests do you want to keep alive, timeout for the keep alive. Yeah, we need to just like have connections persisting between the proxy and the backend, rather than establishing new connection all the time. There is new request, just reuse the already existing connections. Good for performance. This block here is just for monitoring Nginx and monitoring Nginx request by the glow root. But what I was emphasizing the other time is that it's allowing port 80 and then everything, because all the IP addresses are allowed. Basically, this is allowing access from all the IP addresses as the default server, and it is doing a redirect to 302. Okay, meaning everything that hits port 80 is going to be redirected to 302. I think it's a permanent redirect to 443, which is now going to be this second block. Okay, and yeah, there's not much in this file, but it's like including the upstream configuration, and the SSL related configuration are defined in this file, which is static.conf. Yeah, you see also permission denied. Sorry, sudo. Yeah, you see it's a self-signed certificate that we talked about. The Elman parameters file, where is it? SSL session timeout, performance related, and so forth and so forth. Header configuration and so forth and so forth. So this file, you can change your parameters here comfortably, and Ansible is not going to rewrite whatever that you've set here. But here, the default.conf file, notice at the very beginning here that it's telling you that this is Ansible automatic auto-generated file. If you make changes to this, Ansible is going to come back if you run the script, and it's going to rewrite. Yeah, so you need to like be making your changes under maybe default static to mean non-change, like you can change things there, but Ansible is not going to change that, in from that understanding, that static in the sense that Ansible is not going to change that. You can change manually, and Ansible is not going to touch that. It's creating that file once. Yeah. Okay. So my deploy is completed now. Yeah. And you can see that all the tasks. We have changes to the local host deployment server. We have changes to the DHIS. We have changes to the monitor, Postgres, and proxy. We don't have changes to the backup host because we didn't configure that, and we don't have changes to the WireGuard because we didn't configure, we didn't flip the switch to enable the WireGuard in our infrastructure. Okay, now we're gonna have a session or a separate video for that. So right now I can go to my browser and put the IP address, just plain IP address, and just use this .19, our proxy IP address. And it's telling me that this site is not trusted, certificate is self-signed, but we're gonna proceed. You see, trust, it's a self-signed certificate. I can trust it, I don't know, always trust or whatever, but it doesn't matter. You can just proceed to this site regardless. Visit the website and you'll see that it's gonna rewrite to the /DHIS. If you see the domain right now, you see it's rewriting to /DHIS because that is what is how the proxy is configured. Yeah, you see this line here, rewrite everything that comes en route to DHIS. You can enable that or disable that from within the inventory host file. You can see that our host file, or our, you know, our instance line had that enabled with proxy rewrite set to true. It means that if everything hits /root, it's rewriting by default. But if this was false, then you would have to append /DHIS for you to be able to access your instance. Okay. By default, it's coming with admin district. Yeah, not now. Yeah, and on top of that, we have monitoring server, glowroot, the same IP address, but now /glowroot, DHIS, glowroot. See, the same admin district. Okay, we don't have to save anything. And we have also, let me just rewrite this, we have Moonin set up here. Admin, server monitoring now. Yeah, Moonin can monitor all the things. Still, other dashboards are still like coming right now. Yeah, but all these servers, they are running across Proxmox cluster. Proxy is here. You see, glowroot is here. I can even go to the console. Say, try to log in from the console. VMware, Proxmox console. Ktito is my username, my password. Oh, see, I'm logged into the proxy. Yeah, and I can like sudo ss -p. Run the same commands that I was running from within SSH. Okay, all the things that was running from. So this is a distributed environment, and I've actually explained, how you can just do that, achieve that with Proxmox cluster. Another thing is that it doesn't really matter the virtualization backend that you're running on. You could be on VMware vSphere, you could be on Proxmox, you could be just running VMs using KVM or whatnot and whatnot. But the only thing that you need working before you begin is connectivity between your deployment server and the backend servers, and then you're good to go. You should make sure that your sudo password is working, SSH password is working, and so forth. Otherwise, let's stop there.